Assalamualaikum and good day everyone. My name is Akmal Zaini. I am from Group 3 and our group will present an article journal from Trend in Science, which is the title of the article is Heavy Metals in Marsh Clam, Polymer Soda Expansa as Bioindicators for Pollution in Industrial and Sand Mining Area of Kelantan River Basin, Malaysia. The introduction of the article is the Kelantan River is the major river in Peninsular Malaysia, has shown increasing levels of heavy metals pollution from anthropogenic activities such as industrialization, agricultural practice, and the discharging of domestic sewage. Sand mining in the Kelantan River has constantly degraded the riverbed and has caused waterway siltation, thus deteriorating water quality, which has greatly depleted the fish and benthic organism populations. Contamination of the river with various kinds of pollutant enriched with heavy metals caused by sand mining might be the main reason of these local biodiversity shifts. Excessive consumption of bivalve, which have been bioaccumulated with non-essential metals such as cadmium, arsenic, mercury, plumber, nickel, and chromium, which are toxic to organisms even at low concentrations, may impair human health. Bivalves, known as filter feeders, for suspended particles within water columns that may be contaminated with numerous contaminants including heavy metal obtained from either anthropogenic activities or natural emissions. They tend to concentrate contaminant at a much higher level than the natural background concentration in the environment. Therefore, they are the most suitable bioindicators to observe heavy metal pollution in the aquatic ecosystem. The accumulated heavy metals in marsh clams reach human via food chain, and chronic illness probably can be induced in human if these metal polluted marsh clams are consumed. Thus, it is crucial to determine the concentration of heavy metal in marsh clam to assess the potential human health risk of marsh clam consumption. The permissible limits of each heavy metal in food have been set by the Malaysia Food Safety and Food Regulation 1985, the Food Agricultural Organization, the World Health Organization, the Ministry of Health Thailand, and the Food and Drug Administration of United States in order to determine whether marsh clams are edible. Next, the study's objective is to evaluate the contamination levels of heavy metals in the Kelantan River using polymer soda expansa as a bioindicator for 4 heavy metals, which is copper, zinc, cadmium, and plumber. Methods used is analytical method. The homogeneous samples were weighed into sizes of 2.5 gram in petri dish. It involved an aqua regia digestion procedure consisting of digesting the samples on a hot plate with a mixture of hydrochloric acid and nitric acid as prescribed by Kamaruzaman ETAL and Ibadi ETAL. The nitric acid reacted with concentrated hydrochloric acid to form aqua regia. After filtration, the samples were prepared for determination of cadmium, copper, plumber, and zinc by using a flame atomic absorption spectrometer model PIN AACLE 900F per kilo with detection limits for zinc, plumber, cadmium, and copper of zinc 0.75, 0.75, 0.9, and 1.5 ppm respectively.
Hello, today I want to discuss about the heavy metals in marsh clams. So based on figure 2, the Kelantan River in Tumpat and the Semarak River in Tok Bali have much higher zinc concentration with 194 plus minus 0.09 and 196 plus minus 0.16 mg per kilogram. When compared to the Kelantan River in Tumpat, the Semarak River in Tok Bali had the greatest zinc content, which might be attributed to significant mining, shipping, and fish boat activities. Lead concentration were found in all marsh clams from both locations. The average lead values in this species were 4.4 plus minus 0.1 mg per kilogram in the Kelantan River and 4.6 plus minus 0.02 mg per kilogram in the Semarak River. These metals are poisonous to clams, and these metals are readily to eliminated by the body. Cadmium concentration in marsh clams from the Samara and Genting River were 2.2 and 2.5 milligram per kilogram. Actually, cadmium is used in the production of batteries, anti-corrosion coatings for metals, and bearing alloys. So for copper concentration in the soft tissue of marsh clams were found to be 7.9 plus minus 0.04 milligram per kilogram at two distinct locations along the Genting River in Tumpat, Kelantan. For copper concentration in the Smart River were lower than the Genting River, which is 6.2 milligram 6.2 plus minus 0.05 milligram per kilogram. Copper at a greater concentration may act as a biocide and protecting maritime vessels against biofouling. Next is the effect of size on the concentration of heavy metals. So based on figure 3, marsh clams of some smaller size exhibited greater metal contents than those of larger and medium sizes. Copper concentration in the Samara River, for example, revealed that the smaller marsh clams had higher concentration than the medium and large size of marsh clams. So furthermore, cadmium bioaccumulation was greater in the medium size, while copper was higher in the small size, and lead bioaccumulation was higher in the small size of marsh clams. It is showing that bioaccumulation patterns were inconsistent. Amount of trace metals in clams are affected by the geographical, biological variable, and temporal. So in addition, the highest quantities of heavy metals were detected in marsh clams of small and medium size. This is due to the fact that tiny shells have a better potential to acquire metals than large shells. According to figure 4, it is discussed about the moisture content versus length of marsh clams. So the moisture content of marsh clams was shown to be positively correlated with their length, indicating that the size of marsh clams, particularly big and medium size, may impact the moisture content. So marsh clams are more susceptible to microbial deterioration due to their increased moisture content. The oxidative breakdown of polyunsaturated fatty acid will be reduced when the quality of marsh clams improve over time. So for the next, the Malaysian government has established the maximum contamination levels of zinc, lead, cadmium, and copper as 100.0, 2.0, 1.0, and 30.0 milligram per kilogram, based on the allowable limit specified by the Malaysia Food Act.
Hello, in my part, I will discuss about figure 5, which is pollution level of Polymethoda aspensa, which is massa cell. From the result, we can see that the lowest concentration is copper. The results show that only copper concentration were lower than the Malaysian Food Regulation authorized level. The other concentration like zinc, lead, and cadmium is to exceed the acceptable limits. But for the cadmium concentration does not exceed the US Drug Administration safety level. It is indicating that the cow is safe to eat. We can conclude that the article is about pollutants that made by industrial and sand mining site. It is because the article shows the heavy metal found in tissue of marsh clam. The amount of zinc, lead, cadmium in the marsh clam were higher than the Malaysian Food Regulation and the FAO maximum WHO acceptable value. Humans need to be careful while having marsh clam because long-term consumption can cause a variety health problem, for example, coral real. Finally, this paper demonstrates how critical it is to monitor heavy metal concentration in the Kelantan River in industrial and sand mining in order to reduce the risk to human health. Okay, that's all from our team. I hope all of you enjoy about this video. Okay, please comment and ask the question. Thank you.